Good morning, dear friends and dear students. It's my honor and privilege to be here for my favorite course, Flight Mechanics. I am discussing about aircraft performance. In this respect, I have covered the basics of atmosphere, thrust required, power required, lift, drag polar, condition for maximum lift, minimum drag. We have derived the other equations. Today I am going to discuss about the steepest climb of airplane. This covers following topics, that is steepest climb, that is maximum climb angle, variation of climb angle, relation between climb angle and the rate of climb, general equation of climb, effect of altitude in rate of climb and ceiling. So here we will see we have already discussed about the rate of climb. So this rate of climb means, if this is I will draw the aircraft. This is the horizontal. If your aircraft is moving in this direction with velocity v, this is the reference fuselage reference line. This is the FRL, and I will draw the thrust from here. This is the thrust available. So there is a flight path angle. Flight path angle gamma. This gamma, it is called the flight path angle. Then we have angle of attack alpha. This is the angle between V and FRL. So this is your alpha from here to here. This is the alpha, and then we have one alpha t. This is the angle of thrust direction between FRL and TA. It is denoted by alpha t. So these are the three angles, and we have discussed that if this is the velocity v, this is the horizontal velocity vh, and there will be a vertical velocity vc. This vc is rate of climb, and for a better aircraft, gamma RAC should be maximum, vc or rate of climb should be maximum. This we have discussed, and in this class also we will be discussing this all issues. So steepest climb, or it is called maximum climb angle. A climbing flight with the maximum climb angle is referred to as the steepest climb. So if you have the gamma maximum, then it is a steepest climb. Gamma should be maximum. In a takeoff operation, it is of utmost interest in clearing obstacles such as mountains, trees and buildings at the end of the runway. So the aircraft which is having more gamma maximum, that is better to cross the hills and all. Steepest climb is the upper limit of the climb angle which is possible. Some aircraft fastest climb is more important than the steepest climb, and also vice versa. So some aircraft needs fastest climb, another needs steepest climb. So it is as per the requirement of the aircraft. Airworthiness drive the steepest climb, and performance drives the fastest climb. So for airworthiness, it should be steepest climb, gamma should be maximum, and for the performance point, the fastest climb VC is important. How much fast it is there, that is required. Maximum climb angle is a function of the engine power, that is propeller engine, and thrust, that is the jet engine, speed, weight, CG, altitude, elevator control, and so on. So maximum climb angle, that is gamma maximum, is depend upon the engine power, then thrust, then speed, weight, CG location, altitude, elevator control power. This is the parameter in which these things are affecting. Now I will discuss about variation of climb angle with power, thrust, and the weight. So if you see here, to increase the climb angle, the pilot must increase the engine power, that's PA. The highest climb angle will obtain when the engine thrust is at the maximum and the aircraft weight is minimum. So we can see that the VC is equal to TA minus or PA minus PR divided by W, PR. So this is the excess power. So to have the maximum rate of climb, your power available in the engine should be maximum, PR should be the minimum, and weight of the aircraft should be minimum. So if you see here, P minimum or the T minimum here, and as you increase this, your rate of climb, that is the gamma, is also increasing. And here is the maximum. And this will be at tau is equal to 1 at a full throttle. This is the at full throttle. So this, and here also if you see weight, as you increase at a minimum weight, you have the maximum, this thing. And at takeoff weight, your climb will be minimum. So relation between climb angle and the rate of climb. The aircraft speed must be varied to a specified value for steepest climb. So if you see here, we have here rate of climb. Here we have in this diagram, we have the rate of climb maximum, that is angle maximum, gamma maximum at this point where you have gamma maximum, but the rate of climb will not be maximum. It will be here from where it start reverting back. So this is the gamma for rate of climb maximum. So gamma for rate of climb maximum will be less than the maximum climb angle. So the aircraft speed must be varied to a specified value for the steepest climb. Pilot can maximize either the rate of climb, that is fastest climb, or the climb angle, that is steepest climb. As the pilot increases the rate of climb, the climb angle will increase. This will continue up to the fixed point where climb angle will be decreased. So up to here, climb angle will start falling here again. Therefore, at one angle, steepest climb happens, while at another climb angle, fastest climb occurs. So this is the fastest climb. Fastest climb angle, and this is the steepest climb angle. This is the climb. Okay. So this is your angle here. This is this, and this is the this. So this we have to take care of. Now general equation for the climb, which we have already seen, that gamma is equal to sine inverse T minus D by W. Gamma maximum is equal to sine inverse T should be maximum, D should be minimum, weight should be minimum. So sine inverse T max minus D minimum by W minimum. We know that L minus W cos gamma is equal to 0, or gamma is equal to cos inverse L by W. So for maximum range, for maximum angle, gamma maximum is equal to cos inverse L maximum by W minimum. So for rate of climb for steepest climb is, so rate of climb for steepest climb is, rate of climb maximum, gamma maximum is equal to V at gamma maximum sine gamma maximum. V sine gamma, V should be maximum and gamma should be maximum. Then you will get rate of climb maximum. So it is rate of climb maximum means it is that angle at which you are getting fastest climb, and this is the highest climb angle. So now we will further discuss the same thing which we have also discussed in my previous lectures. So here is the aircraft. This has got the horizontal here. This is your velocity of the aircraft, velocity direction. This is your FRL. This is the FRL, and here we have the direction of the thrust. The lift will be perpendicular to this velocity V. Drag will be in the same direction. Weight will be towards the ground. So here we have L, D and W. If you see here this velocity V, we can divide into two components. One is VH, another is VC. This VC is equal to V sine gamma. This is the gamma angle. This is the flight path angle. So VC, that is a vertical angle, vertical speed or rate of climb is equal to V sine gamma. So now we can see here this drag is equal to TA cos alpha T minus W sine gamma, and this lift is equal to L cos gamma minus TA sine alpha T, this one and this one. D for the drag for the steady and level flight is equal to T cos alpha T, dragged at steady level. From figure 2 we can see here, this is the 2, that VC is equal to V sine gamma. From this equation 1, finding the value of sine gamma, so W sine gamma is equal to TA cos alpha T minus D. So sine gamma is equal to TA cos alpha T minus D by W. Putting this sine gamma in equation number 3, we will get here in this. So VC is equal to V T cos alpha T minus D by W. So we can write here if TA is equal to TA by W is less than 1 and gamma is also less than 1. So we will get here D is equal to TA cos alpha T. So now VC, we will see that this VC is equal to V TA minus TR by W, and TA into V is equal to power TA and TR into V is equal to power required by W. We can write it as a Pxs by W. This equation is for a small value of alpha T and the V. As of now, PA we don't have discussed, but we know about the PR, and this PR is given by CD naught rho V cube by 2 W by S plus CD naught L into V plus 2 W by S pi E aspect ratio rho V into W. We draw the plot of power available versus velocity. PA we get from the experiment, and this tau is a throttle setting angle. Maximum is tau is equal to 1. So here we are starting from tau, the throttle setting angle at PA and the velocity graph 0.5, 0.6, 0.7, 0.8, 0.9 and the final is the 1. 1 means it is 100% full throttle is given. Effect of altitude in rate of climb. So the general aviation plot for PA and PR, PA changes with throttle setting tau. So if you see here, PA in horsepower, and here it is speed 50, 75, 100 up to 200. It is here. So this is the dotted line here. This line is power required, and these lines are the power available at different throttle. And if I draw this thing in rate of climb, this is the rate of climb versus the velocity of the aircraft. So this point, this is the absolute maximum air speed, and this will happen at altitude also. So this is the altitude, this is the highest velocity which we can get. So here if you see, you may have one more velocity, but this velocity is less than the stall velocity. So this area we will not take. This area is not acceptable. Only this area is acceptable. So only one point is there, which is the maximum velocity up to which aircraft can fly. So PR is equal to PA at the point 1 here, and here also we have the point 1. Point 1 is known as the maximum level flight speed of the airplane. If you fly above this speed, there will be a sink. You will attain 0 rate of climb, but lower side not possible. Only one speed is possible, that is higher side only. So only higher side velocity, that is this side only acceptable, not below the stall speed. Effect of altitude on the rate of climb, it is continued. So if I increase now altitude from sea level to some height, your PR will go up and PA will go down. So initially it was here, now it has gone up. And if you see here, initially it was here, now it has shifted. Your altitude is also shifted. Your velocity, maximum velocity is also reduced. As you increase the altitude, your maximum velocity will also decrease. As you go further, more throttle is required, your excess power is reduced, now more, and it will come further near the maximum velocity is reduced. Maximum velocity reduced. And here you have the 0 rate of climb. So at higher altitude, PA going down, PR is increasing, maximum speed is decreasing. So here this you can see, as you go up and up, your maximum speed of the aircraft will be decreasing. Depiction of service ceiling and the absolute ceiling by the help of PA and the velocity. So here we can see that in this we have the two cases. This is the absolute ceiling. This is the service ceiling. Okay. So if you see here in this and in this, so if you are putting somewhere 0.9, very small amount of excess power is there. This excess power is only to give up to here, which will give 100 feet per minute rate of climb. So this is the service ceiling, where at the full you are only going to take 100 feet per minute. This is the point. So service ceiling is that point of altitude in which aircraft gives the rate of climb at 100 feet per minute or 0.5 meter per second. Absolute ceiling is that height where rate of climb is 0, figure 2. So if you see here, the rate of climb is here 0, and this is called the absolute ceiling. Next lecture I am going to take forces acting during the climb, most economical climb, time to climb, fuel needed to climb, distance traveled during the climb, ground effect, descent flight. My references are Anderson J.D., Aircraft Performance and Design, International Edition, McGraw-Hill's, first edition, 1999. Ashley M.E., Aircraft Performance, Theory and Practices, AIA Education Series, AIA. Any questions you can ask to me in this email, yddwivedhi@gmail.com. Please do like and subscribe this channel. So I feel that you are understanding. Anywhere you feel that it is not correct or there is some problem in explanation and all, please do comment, send me in this mail. I will try to rectify the problem. Till then, goodbye. See you. Thank you very much for joining this session. We will meet you soon.
Like, share and subscribe. Hit the bell icon for more updates.